Biobombs! My name is Anvita and today we're going to be discussing the first 4 chapters of pre-algebra. Today's topics include types of numbers, properties of numbers, the order of operations which includes PEMDAS, and properties of exponents. So let's get started with numbers. Numbers can be classified into different groups where each group has certain properties. So the first group is called natural numbers, or more commonly called counting numbers. These numbers are called n, and they include numbers greater than or equal to 1, like 1, 2, 3, 4. The next group is called whole numbers. This group has all natural numbers plus the number 0, and it's called W. Since 0 is a non-negative number, it's not considered a natural number. The group after whole numbers is called integers. This group is called Z and includes whole numbers and natural numbers, and now even negative numbers. Some examples are -2, -1, 0, 1, and more. After integers is rational numbers. This group is called Q and includes fractions and decimals which are terminating and repeating, like 2/5, 2/4, 3/8, and 0.125. After natural numbers comes a group called real numbers. It's called R and includes all groups of numbers except complex numbers, which we will talk about soon. Another group with a similar name after rational numbers is called irrational numbers. This group is within real numbers but not within rational numbers. This group includes numbers like square root 3, 1/3, pi, and more. They are non-terminating and non-repeating numbers. All of the groups we talked about so far fall under the category of complex numbers, which are known as C. These numbers are written out as a plus bi, where I is the square root of -1. By taking different numbers in place of a and b, all numbers can fall into this group. Let's move on to the order of operations where the acronym PEMDAS is used. This acronym stands for parentheses, exponents, multiplication, division, addition, and subtraction. The symbol for each of these operations are as follows. A mnemonic that you can use to easily remember the order of operations is "Please excuse my dear Aunt Sally," where the first letter of each word stands for the first letter of each of the operations. The order in which you calculate is from parentheses to exponents to multiplication to division to addition and finally subtraction, but this rule does have a few exceptions, which we will cover soon. When you are calculating an expression or equation where you have both multiplication and division, you work left to right. You would first do 6 times 4, which is 24, and divide that by 2, where you would get 12. Another example of this is if you have 10 divided by 5 times 4. In this case, you would first do 10 divided by 5, where you get 2, and then multiply it by 4 to get 8. Notice in both cases how we worked left to right because we had both multiplication and division in the expression. When you have addition and subtraction, you follow the same rule by working left to right. For example, if you have 5 plus 3 minus 4, you would first do 5 plus 3, which is 8, and then subtract it by 4 to get 4. Another example is if you have 17 minus 14 plus 12. In this case, you would do 17 minus 14, which is 3, and then add that to 12 to get 15. Notice again how we worked left to right. Now, let's move on to some practice problems. In the first problem that we will try to do is 5 plus 3 squared times the quantity of 6 plus 1. The first step that we would do here is the expression inside parentheses. So you would first do 6 plus 1, which equals 7. The next operation that you would do is the exponent, where you have 3 squared. This equals 9. Now let's rewrite this expression as 5 plus 9 times 7. Now, since you have multiplication and addition, you would first do this operation. You would do 9 times 7, which equals 63, and then add it to 5 to get 68. Another example problem is 6 plus the quantity of 5 squared times 2 divided by the quantity of 15 minus 5. In this expression, we have 2 operations inside parentheses. So first we will do 5 squared times 2, and then we will do 15 minus 5. When you are doing 5 squared minus 2, you first need to expand 5 squared into 25 before multiplying it by 2 to get 50. For 15 minus 5, you would subtract to get 10. Now we can rewrite our expression as 6 plus 50 divided by 10, where we would now do 50 divided by 10 to get 5. If we rewrite our expression once more, we can write it as 6 plus 5, where we can add it to get 11. So let's move on to the properties of numbers. There are 3 main properties of addition and 4 main properties of multiplication. The first one we will discuss is the associative property. This property tells you that there can be any groupings of numbers with the final answer still being correct. In addition, you can say that a plus the quantity of b plus c is equal to the quantity of a plus b plus c. This same property can be expressed with the quantity of a times b times c is equivalent to the quantity of a times the quantity of b times c. The second property we will discuss is the commutative property. In this property, it tells you that operations can be written out in any order. So in addition, a plus b is still equal to b plus a, and in multiplication, a times b is still equal to b times a. The next property of addition that we will discuss is the identity property. In this property, a plus 0 is still equal to a, where a retains its identity. In multiplication, a times 1 equals a, where a still retains its identity. The final property we will discuss is the distributive property. This is seen when a times the quantity of b plus c is written out as ab plus bc because the a is being distributed to both terms. Now we will discuss the properties of exponents. There are 6 main properties that you should learn in pre-algebra. The first one is x to the power of m times x to the power of n is equal to x to the power of the quantity of m plus n. Since the bases are the same and they are being multiplied, their exponents can be added. The second property you should know is x to the power of m divided by x to the power of n is equal to x to the power of the quantity of m minus n. Since the bases are the same and being divided, you can subtract the exponents. The next property you should know is x to the power of m to the power of n is equal to x to the power of m times n. The fourth property to know is any number to the power of 0 equals 1. Moving on, the fifth property is x to the power of negative n equals to 1 over x to the power of n. In this case, since the exponent is negative, you take the reciprocal of the number and change the exponent to a positive number. The final property you should know is x to the power of m over n is equal to the nth root of x to the power of m. Let's move on to some examples. So the first one we will try is x to the power of 3 times x to the power of 4. In this case, we use the first property that we learned where x to the power of m times x to the power of n is equal to x to the power of m times n. So we can rewrite our problem as x to the power of 3 plus 4 is equal to x to the power of 7. The next problem we will try is x to the power of 10 divided by x to the power of 4. Here, we can use the property of x to the power of m divided by x to the power of n is equal to x to the power of m minus n. So we can rewrite our expression as x to the power of 10 minus 4 is equal to x to the power of 6. The third problem we will try is 10 to the power of 5 to the power of 6. In this case, we use the property where x to the power of m is taken to the power of n and rewritten as x to the power of m times n. So here we can rewrite our expression as 10 to the power of 5 times 6, which is 10 to the power of 30. The fourth problem we will try is 17 to the power of 0. Since we know that any number to the power of 0 equals 1, we know that 17 to the power of 0 also equals 1. The next problem we will try is 3 to the power of negative 1. In this case, it equals to 1/3 because any number to the power of a negative number is rewritten as its reciprocal with the positive exponent. The final problem we will try is 8 to the power of 2/3. In this case, we use the property where x to the power of m over n is the nth root of x power m. So we can write it out as the cube root of 8 squared, which is the cube root of 64, and this value is equal to 4. Stay tuned for more videos on math. Thank you!